Hi everyone. Um, we are going to talk about the Pythagorean theorem now. Um, this is something that is part of the grade 8 curriculum, and so normally I do this as review, but I know that grade 8 last year was a little odd, and quite a few of you didn't learn this, so I'm just trying to wrap my head around teaching this as a first time thing instead of um, a review without having time to go and do the whole prep thing that I would like to do. So what I'm going to do is I'm just going to explain this the way I have, and then I will try and find a couple of other resources online. I know there are some places online that explain this really well and give some more examples in case what I do isn't enough. I had a prof once who used to call the Pythagorean theorem the goat bridge because it was the first step into real math. This is using higher concepts, more complicated things, and so he called it the goat bridge. And so before we do anything else, we should do some vocabulary. And so the first thing is a right triangle is one that has a 90-degree angle. Oops. I have and we show in the this triangle angle. Now, if it helps to write out a squared plus b squared, and then the longest side of the triangle is called the hypotenuse. Your equation, you can do that. All right, and the hypotenuse is always the one that's across from the right angle. Okay, and then I have a little graphic here to help you remember because I think this is hilarious. Paste. There we go. There's the hypotenuse. The hippopotenuse. I just think it's funny. So if that helps you remember it, then that's awesome, and that helps you remember it, but you don't have to. Don't worry about any of the other things marked on this as for other math, but this is the hippopotenuse. It's the hypotenuse. It's the long one. Okay. And then the other sides of the triangle are called legs. So this is a leg here, and this is another leg. Okay. And when we have a triangle, the way we label it is sort of just tradition more than anything. We label the hypotenuse with C, and the two sides, the two legs, are A and B. And when we have it labeled this way, then the length of A squared plus the length of B squared equals the length of C squared. Okay, that is the Pythagorean theorem, and it applies to every right triangle and only to right triangles. All right, so here, the triangles don't have to be labeled A squared plus B squared equals C squared. You could have a triangle labeled like this, and in this case, the formula would be n squared plus m squared equals r squared, or m squared plus n squared equals r squared. The essential thing is that the hypotenuse is the one that's by itself. Okay, this one in the middle here would be w squared plus p squared equals k squared, or p squared plus w squared equals k squared. This one here is a trick question, not a right triangle. All right, let's do an example. So Pythagoras doesn't apply. All right, so there is no formula for that one because Pythagoras is not a thing. All right. Let's do an example here. We have here, we have a triangle. It has a right angle, so it's a right triangle, and we can use Pythagoras. And some students find it helpful to actually write out the a squared plus b squared equals c squared just as a reminder of what the formula is. All right, and then we're going to change it into what's actually in this question. So let's make this t squared plus u squared equals v squared. And then since t is 8, this becomes 8 squared And since u is 9, this becomes 9 squared. And we don't know what v is, so we're just going to leave that as v squared. And 8 squared is 64, and 9 squared is 81, so that equals v squared. And 64 plus 81 is 145, so that equals v squared. And now you have the question of, well, I don't care what v squared is, I want to know what v is. How do I find out what v is? Well, just like when we were doing the algebra, if something was multiplied, you would divide it to isolate the variable, and if something had been added, you would subtract it, because those are inverse operations. The inverse of squaring is to take the square root. So our next line is that 145 is the square root of v squared. Oh, sorry, the square root of 145 is the square root of v squared. And the square root of 145 is v. Okay, so the square root, this is kind of an aside, the square root of v squared is v. All right, because in here we took the v, we squared it, and then we unsquared it. The square root is unsquaring something. Okay, and then you take your calculator and you get that v equals, and you'll find the calculator button, or the square root button on your calculator. I can help you if you need that. And that comes out to 12.04 and a bunch of other digits. So we'll just leave it at 12.04. All right. One more example. This one is, this time, there's two complications in this one. One is that we're looking for a side length, a leg, instead of the hypotenuse. And my a squared plus b squared equals c squared formula isn't going to work on this one because c is not the hypotenuse. So what I would recommend you do is label this as x, y, and z. That's a script z, because my printed z's look too much like 2's. Okay. And now our equation, or our formula for this, is x squared plus y squared equals z squared. Leg squared plus leg squared equals hypotenuse squared. And my value for x is c, so this is going to be c squared. And my value for y is 24, so this is 24 squared. And my value for z is 26 squared. Okay. Now, really strong piece of advice. Do not go minus 24 squared minus 24 squared. Don't write this down. I'm just going to show you what happens. Plus 24 squared equals 26 squared. If I go minus 24 squared and I go minus 24 squared, I get c squared equals, and an error that many of you will do is you'll change that to 2 squared. And that's incorrect. Okay, so what to do instead to sort of bypass that common error is do your squaring here. And so this is 24 squared, which is, so c squared stays as c squared. My 24 squared, I use my calculator and I get 576. And 26 squared is 676. And nobody expects you to have those values memorized. You'd always get to use a calculator for that. Okay, and now I have some algebra. I'm going to subtract the 576 from both sides. I am left with c squared equals 100. And then I need to isolate my c. I have to get rid of the other c, so I'm going to take the square root of both sides. And so the square root of c squared is c, and the square root of 100 is 10. So the answer here is 10. And then I need to dims. I didn't do that before, but I need to dims. Does it make sense? Okay, if this is 26 and this is 24, so I'm going to look at my diagram and I'm like, okay, if I pretend that I'm going to take this line and curve it around up to here, If that's 24 to here, is that 26? That seems reasonable. This is 10, it's a little less than half of this. Yeah, that seems reasonable. Okay. This one over here, I forgot to dims it, but I got 12.04. That seems reasonable. The hypotenuse is always, 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 always going to be the long side. If it's not, you have made a mistake. Okay. Okay. Um, that is the video that I have. That is the toolkit page that I have for you. Um, all I can suggest is that you just show your work, show your work, show your work, write down the formulas, do the algebra. Okay. And I will see if I can find some other resources to post for you. I know there's all kinds of graphic things that show you that this is true, that it works, that this relationship where the leg squared plus the other leg squared plus the hypotenuse squared does make a square. Or sorry, they are equal. I've got one on my classroom wall actually that you can see. Um, but that's it for this video. So if you could let me know how you do on this at the end of tomorrow, if you're home tomorrow, I'd really appreciate that. Thank you. And I will see you later. Bye.